Hello everyone, welcome to my channel. If you are new to this channel or you haven't yet subscribed, please support us by subscribing. In this video, I have one integral that I would like us to look at. It's the integral of x squared all over the square root of 9 minus x squared dx. Trig substitution application. So this is how we approach it. The integral of x squared all over the square root of 9 minus x squared, and then we have dx. Now, looking at this expression under the square root sign, we have to make sure that there's a 1 in that place there. And so we are forced to factorize this, where 9 is forced to be the common factor, as follows. The integral of x squared all over square root of, like I said, we have 9 as our common factor, open brackets. 9 into 9, it's 1. 9 into x squared, we're going to have x squared over 9, like that. And we have dx. This is our page 1. Now I'm going to rewrite this expression here, x squared over 9, as follows. And I'm going to take square root of 9 as well, positive square root. This is the square root of x squared, the integral of x squared all over there to be square root of 9, multiplied by the square root of 1 minus, watch how I change that to x all over 3, and I square the whole of that expression, and I have dx. Right, and square root of 9, you agree with me, is 3, so we can take 3 out, and remember 3 is dividing, so we have 1 over 3, the integral of x squared all over, this part is now going to be square root of 1 minus x over 3 all squared, like that, and then we have dx. Now, at this point, we have trig substitution coming in, taking us to the second page, which is page 2. Let me change this page here, and I'm going to turn these papers. I'm going to turn, let me just remove these ones here. Page 2. So what we have now is, like I said, we're going to now say, let this expression there, that part there, x over 3, we're going to let sine theta be equal to x over 3. Remember, when you have 1 minus something squared, it's the sign substitution. When you have, sometimes you can also use a cosine, but we prefer using the sign substitution. But if you have 1 plus something squared, it has to be the tan substitution. Remember those techniques. At this point, it's important for me to draw a right angled triangle in which our theta is clearly defined. So this is our angle theta, and by definition, remember, sine is opposite of hypotenuse. And therefore, by Pythagoras theorem, the adjacent side has to be the square root of that squared, which is 9, minus that squared, x squared, like so. And then we take square root of that. Now, that's the first part. The second part would be to solve for theta from there. You'd agree with me that theta is actually going to be arc sine or sine inverse of x over 3. The other equation would be to multiply, first of all, by 3 both sides, and then differentiate with theta with respect to x. So what you're going to get is the following. You're going to get 3 derivative of sine theta is actually cos theta, and then d theta. On the right, you just have dx. That's what you have now. So that integral can be transformed then as follows. I'm going to say that integral is transformed into the integral of, we have 1 over 3 outside. Instead of x squared here, remember, if you make sine, if you make x subject to formula here, you're going to get x is equal to 3 sine of theta there. Now, we need that in the numerator, so it will be 3 sine theta, but it has to be squared. Remember, it's x squared there. It's x squared, so we have to square it all over. In the denominator, we have square root of, notice here now, square root of 1 minus, in place of x over 3, we're going to have sine. So it will be 1 minus sine squared of theta, and in the place of dx there, I'm going to have 3 cos theta d theta, 3 cos of theta d theta. There is your trig substitution totally effected. Now we have to simplify this part and that part. On that one, I want to remind you of something here, that trig identities, if you remember trig identities, we said sine squared theta plus cos squared theta equals 1, and therefore from here you can see that cos squared of theta equals 1 minus sine squared theta, and therefore if you take positive square root both sides, cos squared of theta, you must get positive square root of 1 minus sine squared theta. This part is what you see in the denominator here. So basically on the right, on the left, you agree with me that it's just cos theta. Cos theta equals that. So now we are basically saying this, take the 3 out and the 3 out. So we can have 3 times 3. That's that. It has to be squared, by the way. So this 3 will be squared times that 3 out like that. We have 1, obviously, that one here in the numerator. And we're saying we're dividing this by 3. And what are we saying? We're multiplying this by the integral of this part here, obviously. Now we're left with sine squared of theta. Remember, 9 is this one here. And then that 3 is out. We're multiplying this by cosine of theta d theta. And we're dividing this by this one. I told you already that is just cos theta, the positive square root of that cos of theta. So these cancel. And then this 3 cancels that 3. So outside there on page 3, what we have now is, notice this part here is going to be 9 because 3 squared is 9 times the integral of sine squared theta d theta. Now at this point, I want to remind you of another trig identity. The other trig identity that I want to remind you is basically this one. Cosine of 2 theta has 3 expressions. It's cos squared of theta minus sine squared of theta. The other one is 2 cos squared of theta minus 1, and the third one is 1 minus 2 sine squared of theta. So when you look at this part here, is that part there, which means we are talking now about cosine of 2 theta being equal to 1 minus sine of sine squared of theta. 2 of the 2 sine squared theta, like that. We have to make sine squared theta subject of formula. You agree with me that I'm going to have 2 sine squared of theta equals 1 minus cos of 2 theta. Divide by 2 both sides. Sine squared of theta equals half of 1 minus cos of 2 theta. So this is what must take the place of sine squared. So that integral then changes to 9 times the integral of half, open brackets, 1 minus cos of 2 theta, and then I have d theta outside. Right, now we need to move on. So now I'm going to take half out because it's a constant. So we have 9 over 2, and then the integral of, allow me to use brackets, we can have 1 minus cos of 2 theta d theta, like so. Right, distributing the integral and d theta, keeping 9 over 2 outside, we have 9 over 2, open brackets, and what do we have? We have the integral of 1 d theta minus the integral of cos 2 theta d theta, like that, taking us to page 4. And what am I saying? What we're saying now is that integral there and changes to 9 over 2 outside, and we're saying the integral of 1 with respect to theta is just theta minus the integral of cos 2 theta. You agree with me that it's sine of 2 theta all over 2. You can use substitution there to verify that. And then we have to say plus c. Now, continuing, I'm going to have to distribute the 9 over 2. You are going to agree with me that the answer is 9 over 2 times theta, and then minus 9 over 4 and sine of 2 theta plus c. I'm going to have to break this one down. So this is 9 over 2 theta minus 9 over 4. This is 2 sine theta cos theta, double angle formula for sine there, and this cancels there. You have 2. So the answer is 9 over 2 theta minus 9 over 2 sine theta cos theta, and then plus c. Now let's go back to our triangle. Our triangle that I told you we need, here is the triangle that we need. Look at this triangle here. Sine is x over 3, cosine need to be square root of 9 minus x squared all over 3. So now we're changing. Let me move this one down. We're now changing. I hope you can see the triangle here. You can't. Let me move down. There is our triangle. Like I said, sine is x over 3 and cosine is square root of 9 squared and 9 minus x squared all over 3. So here we now are saying this is 9 over 2. Let me keep theta for now, minus 9 over 2. Instead of x, I'm going to have, instead of sine theta, I'm going to have x over 3. And instead of this one, I'm going to have square root of 9 minus x squared all over 3, and then plus c. There you go. And of course, we're going to get rid of theta shortly. So this is that part there. You can see that the 3 and the 3 will cancel that 9 there. So you have 1 over 2x times that. And this is what you have at the beginning here. So now we are basically saying, if you agree with me, now I'm basically saying this is 9 over 2 theta minus half of x, the square root of 9 minus x squared plus c. Now let's work on theta. What is the value of theta? Well, here is the value of theta. It's sine inverse of x over 3, so I must get rid of that. Taking us to the last step, this is 9 over 2 sine inverse of x over 3, and then minus half x times square root of 9 minus x squared plus c. That's our final solution to this integral. Right, this is trig substitution as a technique of integration. Now, if you have questions on this, please put them up in the comment section. Your feedback remains important. I was requested to bring up questions involving trig substitution, and this is just one of them. Many more will be coming your way. All right, if you're new to the channel, like I said at the beginning, support us by subscribing, providing us feedback. Like I've said, we truly value your feedback. All right, see you in the next one.